Okay, we've solved systems by graphing, we've solved systems by substitution, we've solved systems by elimination. We talked about special cases. We graphed inequalities. So now we're going to graph a system of inequalities. So I'm going to graph two different inequalities on the same graph. We're going to talk about where is the actual answer. So the first equation I'm going to graph is the y is less than 3x plus 2. So I'm going to start at 2 on the y-axis. And then my slope is negative 3x over 1, which means I'm going to go down 3, right 1. Then I'm going to go up 3, left 1. And then because of this symbol, I'm going to have a dotted line. And then because it's less than, I'm going to shade below the line. So dashed line or dotted. And then I'm shading below that line. So everything below here. Now I'm just doing a rough sketch for right now because I want to talk about what happens later on. So now I'm going to grab another color. I'm going to grab the second, I'm going to graph the second one. So I'm going to start at negative 1 on the y-axis. I'm going to go up 1 over 1. So up 1 over 1. Now my symbol is greater than or equal to. Because it's or equal to, it's going to be a solid line. And then because it's greater than, I'm going to shade above that line. So everything above this line, see solid. And everything above this line is shaded. And so now what happens if I got two different colors going on, it looks like a disaster. But my true answer is where the two shadings overlap. So now I'm going to come in with my highlighter and I'm going to highlight where the purple and, I don't know, what is that, turquoise overlap. So this is going to be the solution to both systems. And so this is my true answer. And in fact, I can go back in here and I can erase all this part where the shading did not overlap. So now I have my true answer. And now we're starting to get to the heart of why are we checking this? And so now I'm looking at, is the point 0, 1 a solution to the system? So what I would do is I would graph the point 0, 1, so x value 0, y value 1, and I ask, is that in my shaded area? And in fact, it is in that shaded area, so yes, it's a solution. And so that's kind of what we're looking at in this chapter, or in this section. So we're going to try another one. We're going to go ahead and graph in red for this one. So I have negative 1. I'm going to start on my y-axis. And then my slope is up 1 over 1. So up 1 over 1. And then because my symbol is greater than, I'm going to shade above the line. And then it's going to be dashed because there is no line underneath. So I'm going to draw a dashed line. And greater than means I'm shading above. So I'm going to shade everything above the line. Okay, now I'm going to go ahead and grab another color. And we're going to start at positive 1 on the y-axis. And then my slope is negative 1 over 1. So I'm going to go down 1, right 1. And then because my symbol is greater than or equal to, I'm going to shade above the line because it's greater. And then the or equal to means that I have a solid line. And these are all things we look for when we're grading. We're checking all these little bits. And then above means I'm shading above the line. Now my final answer is only where the red and green are overlapping. So I'm going to grab that highlighter and I'm only going to highlight the portion where the red and green are overlapping. And so then I can grab my eraser and I can erase all the other shading. So that way the only shading that's left is the shading for my answer. And now I can go back to my original question. Is the point 0, 0 a solution to the system? So if I look at my graph, 0, 0 is right here. It is not in the shaded region, so the answer is no. Okay. So now we're going to graph another one. It looks like we're getting a little bit more complicated here. We have y is greater than 1/2 x minus 2, so I'm going to start at -2. And then my slope is 1/2, so I'm going to go up 1 right 2. Or down 1 left 2. Now my symbol is greater than, so that means I'm going to shade above. And my line's going to be dashed or dotted. So I'm going to go ahead and dash my line. And then I'm shading above, so I'm going to go ahead and scribble above my line. Now I'm going to grab another color. And it doesn't look easy to graph this, so I'm going to come off to the side. 8x plus 4y is less than or equal to 12. I'm going to solve for y, so I'm going to subtract 8x on both sides. Now I have 4y is less than or equal to negative 8x plus 12. I divide by 4. So now y is less than or equal to negative 2x plus 3. So I'm going to start at 3. And then I'm going to go down 2, right 1. Or up 2, left 1. And then, based on my inequality symbol, I'm going to shade below because it's less than. And because of the line underneath, I'm going to have a solid line because all points are included. So I'm going to go ahead and draw my solid line. I'm going to go ahead and shade below the line, draw myself a little thing there. Okay, everything here is shaded. And then I'm only going to highlight where the purple and brown overlap. So just this area will be my solution. It's weird how now that purple turns to brown with the highlighter on top of it. I'm going to erase any part of the shading I don't need anymore. So that way my highlighted portion is the only shaded bit left. And now I'm going to check, is 4, 0 a solution? So x value of 4, y value of 0, and it is not in the shaded region, so the answer is no. Okay, next one. Go ahead and graph the first one in green, so I'm going to start at -7. And then my slope is 1 over 1, which is up 1 over 1, up 1, right 1. Or down 1, left 1. And then my symbol is greater than, so it's going to be dashed. And it's going to shade above the line because it's greater. So a dashed, shading above, so give myself, okay, this area. So good at staying inside the lines. Okay, so now I'm going to grab another color. Let's go with pink. And I have to solve for y now. So 3x minus 6y is less than or equal to 12. I move the x over, so minus 3x on both sides. So now I'm left with a negative 6y is less than or equal to negative 3x plus 12, because it's a positive 12. Now I divide everything by negative 6, which begs me to remember what happens if I divide by a negative. Well, my sign has to flip around. So now I have y is greater than or equal to, the negatives cancel, 3 over 6 is really 1/2 x. 12 divided by negative 6 is negative 2. So in my graph, I'm going to start at that negative 2 on the y-axis, and I'm going to go up 1 right 2. Or down 1 left 2. And so now I have to look at my symbol. So I have the line underneath, which means it's going to be a solid line. I'm going to draw a solid line. And then my symbol flipped around, so now I'm shading above the line. So everything above the line is shaded. So now I'm going to grab my highlighter. I'm going to highlight where I have pink and green. So everything in this region is a solution. And my pink turns orange with the highlighter. I can go back and erase anything not in that area. And then I check my point. So is the point for 0 a solution? So x value 4, y value 0. And it's kind of tricky because it's right on the line. But this line is a solid line, so every point on this line is included. So we are good to go. Yes, it's on a solid line. Now, if that was a dashed line, the answer would be no, because anything on a dashed line is not a solution to the system. Okay, next one. Go ahead and graph the first one. So I'm going to start at positive 5 on the y-axis. I'm going to go up 2 over 1. Or down 2 left 1. Now my symbol is less than, so it's going to be dashed and shade below. So dashed and I'm shading below. Now I'm going to go ahead and grab another color. I'm going to start at negative 1. So negative 1 on the y, and then I'm going to go up 2 over 1. 1, 2 over 1. Down 2 over 1. Now this is a greater than or equal to. Greater than means I shade above, and or equal to means a solid line. So I draw my solid line, and I want everything shaded above the line. Ooh, so it gets kind of tricky here. I'm going to grab my highlighter and I'm going to shade only where it's overlapping, which is right perfectly in between those two. So anything in that small little ribbon will be a solution. And I can go back in and I can erase all that extra shading I didn't need. Because really I only want to know is where does the shading overlap. So now I go back to my original point. Is the point 0, 0 a solution? Yes, it's in the shaded region, so it is a solution. Okay, so it looks like I have 2 more examples. Let's move on to this one. We're going to start graphing at positive 8 on the y-axis. We're going to go down 3, right 1. So down 1, 2, 3, right 1. Now if I look at my symbol, it is greater than, so it's going to be a dashed line and shaded above. And so if I can't tell which is above, I start at my line and draw a line straight up. And so everything over here is shaded. So now I'm going to grab a different color. I'm going to start, oh, there's no number there, so that means I'm going to start at 0 on the y-axis, and I'm going to go down 3, right 1. So down 3, right 1, down 3, right 1, up 3, left 1, up 3, left 1. And this is a less than or equal to, so I'm going to shade below, and it's also going to be a dashed line. And so now I grab my handy dandy highlighter and I highlight nothing because none of my shading overlaps. So right away I know 0, 0 is not a solution because there is no overlapping. Which means that really there is no solution for this system because I have no overlapping of the shading. Okay, one last example and we are done for chapter 5. Okay, so graph the solution for y is greater than 1/2 x minus 8. So I'm going to start at -8. I'm going to go up 1, right 2. Or down 1, left 2. It is greater than, so I'm shading above, and no line, so it's dashed. Shading everything above that. So now I'm going to grab another color. I'm going to start at +3 on the y-axis. And my slope is 1/2, so I'm going to go up 1, right 2, up 1, right 2, up 1, right 2. Down 1, left 2. Now this symbol is greater than or equal to means a solid line. Greater than means I shade above. I highlight the portion where only the purple and green are overlapping, or turquoise, teal, whatever you want to call that. And so I can erase all the other shading. And then I check the one point. Is 0, 0 a solution? Well, 0, 0 is right here. It's not in my shaded area, so the answer is no. And that is it for chapter 5.